Welcome to Energy Northwest, powering our region's clean energy future. Over the next 30 minutes, we will give you an in-depth look at how Energy Northwest is helping the region meet its clean energy demands. We will take you inside Columbia Generating Station, show you the rigorous training required to operate a nuclear energy facility, explain how Columbia has responded to events at Fukushima, and show you how used nuclear fuel is stored safely and securely. Energy Northwest is a public power joint operating agency founded in 1957. Our members include more than 24 public power utilities located across Washington state. For more than 50 years, Energy Northwest has been committed to providing reliable, affordable, environmentally responsible power for the Northwest. Our clean energy projects include nuclear, wind, hydroelectric, and solar. Power from each of those projects is provided to utilities at the cost it takes us to produce it. The largest energy generation project we operate is Columbia Generating Station.
Columbia is the Northwest's only nuclear power plant. Online since 1984 and located about 10 miles north of Richland, it produces enough electricity to power approximately 1 million Northwest homes. Columbia is a boiling water reactor. Nuclear fission is used to heat water into steam. For fuel, we use pellets of uranium, much like these simulated pellets.
Each pellet contains as much energy as nearly a ton of coal, 149 gallons of oil, or more than 17 million BTUs of natural gas. The pellets are stacked inside fuel rods and gathered into fuel bundles. The bundles are then inserted into fuel assemblies.
This model shows how the fuel assembly fits together. The actual fuel assemblies, all 764 of them, are each almost 15 feet long.
We submerge the assemblies in highly purified water in the reactor along with 185 control rods. The fuel and control rods together are called the reactor core. In the control room, a team of exceptionally skilled reactor operators begins the fission process by slowly moving control rods out of the core, starting a chain reaction. The heat produced by this reaction boils water within the reactor core and makes steam. The entire system is closely monitored and controlled 24 hours a day, 7 days a week. Steam from the reactor vessel is used to turn 4 large turbines attached to a large generator. Together, they turn 1,800 times each minute, producing about 1,170 megawatts of full-time or baseload electricity.
As the steam leaves the turbines, it's cooled back into water in a special heat exchanger called the condenser. The condenser is filled with thousands of small pipes like you see here. This condenser module is getting ready to be installed. All these pipes are flowing with cool water from the Columbia River. As the hot steam passes by the outside of these cool pipes, it's condensed back into water.
The water inside the pipes absorbs a lot of heat, so we have 6 large cooling towers to remove that extra heat.
Hot water from the condenser is pumped into large canals at the top of each cooling tower. From here, the water is allowed to fall down across special inserts called cooling tower fill.
Large fans pull air across the water, causing the heat to dissipate into the atmosphere as water vapor. At the bottom of the towers, the cool water is collected and pumped back to the condenser to be used again. Columbia Generating Station produces a tremendous amount of electricity from nuclear fuel. But like any fuel, eventually it starts to run out of energy and we have to replenish the supply. Every 2 years, we shut down the reactor to conduct a refueling outage.
Right now I'm standing on the refueling floor and you can see the top of the reactor vessel behind me. During normal operations, things out here are relatively quiet. But during a refueling, this entire floor is transformed into a strictly controlled and highly choreographed work area.
During each outage, we remove the layers of shielding and various components of the reactor vessel and then flood the open cavity with water. Using very detailed procedures, operators move the oldest fuel, which has been in the reactor core for about 6 years, into a pool of water adjacent to the reactor vessel. The remaining fuel is repositioned and new fuel is added to create the best configuration for energy generation. The outage is also an opportunity to do maintenance and upgrades on other equipment that isn't accessible when the plant is operating. It's a busy time for everyone as we move through actions and activities that have been in the planning process for almost 2 years. Thorough planning and attention to detail help ensure the work is done safely and efficiently. This is vitally important so that Columbia Generating Station can be brought back online to provide the region much-needed electricity for another 2-year run. The fuel moved out of the reactor core during the refueling outages is called used fuel. It's often referred to as spent fuel, but that's a misconception. After 6 years in the reactor core, the used fuel still contains about 95% of its energy potential. It could be recycled and reused, as they do in France and Great Britain, but it's not currently done in the U.S. In France, where nuclear power provides 80% of that country's energy, the used fuel is recycled and reused, minimizing the amount of material volume that will ultimately require long-term disposal. Until recycling becomes reality in our country, the used fuel must be stored on-site. This happens every 5 to 6 years when we remove the used fuel from the storage basin, where it has been safely stored underwater, and place it into dry, above-ground storage.
The fuel is housed in large steel and concrete lined casks and then brought here to the Independent Spent Fuel Storage Installation, or ISFSI. There are currently 36 casks of fuel stored here at the ISFSI site.
The stored fuel will remain safely and securely on site until a national repository is built or until the recycling of used fuel becomes available in the United States.
Columbia is a tremendous example of technology, engineering, and safety, but the heart and soul of our plant is the people who work here.
From reactor operators to engineers, chemists to craft workers, health physics specialists to security officers, each person understands and is committed to their role in keeping the plant running.
The region benefits economically by a huge amount each year as a result of the ongoing operation of Columbia.
What is clean?
For me, it's bath time.
Breathing the fresh air.
That's easy. It's a carbon-free source of energy.
With no greenhouse gases.
It's nuclear energy.
Nuclear energy.
Full-time energy, 24/7.
It's about being environmentally responsible.
For now.
And the future.
Nuclear energy. Reliable, affordable, environmentally responsible.
Nuclear power has a real place in our generation of electricity, currently and in the future of our state. It's important for us to understand that for our entire nation.
The Nuclear Regulatory Commission in 1983 granted Columbia Generating Station its initial 40-year operating license through 2023. In 2007, Energy Northwest began the process to have Columbia's license extended for an additional 20 years. The formal application, more than 2,200 pages, was submitted to the NRC in January 2010. Following that, the Energy Northwest team worked with the NRC to gather information relating to safety and potential environmental aspects of a license extension. Based on their thorough, independent reviews and inspections, the NRC concluded license renewal should be granted. The NRC process involved multiple on-site visits, as well as opportunities for public input. In May 2012, the NRC granted the extension, allowing Columbia to operate through 2043.
When they grant that to you, what they are saying is they have done an exhaustive review of how you've maintained your plant and the condition that it's in and their confidence of its ability to run safely into the future. With the original 40-year license, it was never a case of saying we don't believe you can go beyond that, but we are going to require the study to be such that it's going to approve 40 years of operations. You know, I think we all felt from the very beginning that the plants had the capability to run well beyond that.
To the 1,000 employees plus at the Washington State Columbia Generating Station, you have done an excellent job, and I want to thank you and congratulate you for all that you have done to make the day possible. Thank you.
Following the license renewal approval, Energy Northwest employees, former employees, and community leaders gathered to mark the occasion and celebrate the achievement. Washington Governor Chris Gregoire spoke to employees about the importance of nuclear energy to the Northwest and praised employees for providing it safely.
Everybody who's come in contact or knows anything about a nuclear plant knows that safety is number one, top to bottom. And you today are showing your commitment to and your excellence in ensuring that this is a safe, reliable plant.
Though they couldn't be there in person, Senator Patty Murray and Congressman Doc Hastings also offered their praise.
And what's even more impressive is the steadfast commitment from Energy Northwest's management and workers to safety and the environment. These issues are very important to me, and I commend you for your continued attention to keeping the community safe and our environment clean.
I will continue to do everything I can to support your current operations and to encourage the further development of nuclear energy in our state. In my view, Washington State should be a leader when it comes to this job-creating, non-emitting energy source. And all of you here today are leading the way.
This event has been 5 years in the making.
I think it was huge. It was huge on a number of bases. First of all, it's huge for the region. The region benefits economically by a huge amount each year as a result of the ongoing operation of Columbia.
Renewal of Columbia's operating license also extended contributions to the facility's decommissioning fund, resulting in hundreds of millions of dollars in cost reductions for regional ratepayers. Washington State will see the continued employment of a large base of highly skilled, highly trained full-time workers, which also provides economic stability to the Tri-Cities area. State and local governments will see ongoing significant tax revenues. Each year, Energy Northwest pays taxes for the privilege of generating electricity in the state of Washington. These taxes, totaling millions of dollars, directly help local schools and libraries. And local charitable organizations will see ongoing employee support through donations of time and money.
And ultimately, the ratepayers benefit because the ratepayers look for us to generate safe, reliable, cost-effective electricity, and be able to spread out some of our costs over an additional 20 years will allow our production costs and therefore our rates to be even lower into the future.
We have a large number of people that trust us to generate power safely, and being able to respond to these highly unlikely but theoretically possible events is part of keeping the public safe.
What is safe?
For me, it's as simple as using my seatbelt.
It's making sure my kids wear their helmets, even when they don't want to.
It's not about meeting standards, but exceeding them.
It's expecting the unexpected and planning for it.
It's nuclear energy.
Nuclear energy.
And it's my job.
And my job.
Nuclear energy. Reliable, affordable, environmentally responsible.
Reactor scramble, listen up first. Mode switch isn't shut down. APRMs are downscale. RPV pressure is 950 pounds, down slow. Reactor water level is -40 inches, up slow. EOP entries on low RPV level and high drywall pressure.
Mode switch is in shutdown. APRMs are downscale. Reactor pressure 950 pounds, down slow. RPV level -25 inches, up slow. EOP entry conditions on low RPV level and high drywall pressure.
That's all correct. And Bruce, all rods are in.
All rods are in.
Columbia and really all plants in the United States put a great emphasis on training because they realize that the day-to-day operation in the power plant really doesn't provide the necessary practice of skills and tasks that might be necessary during an aberrant situation, some type of accident situation.
Nuclear reactor operations provides both a rewarding and challenging career. Obtaining an initial operator license requires passing a rigorous 18-month training course, as well as testing approved by the Nuclear Regulatory Commission. Even after successfully completing the initial license phase, the training doesn't stop. Every 8 weeks, operating crews are back in the classroom and the simulator for a week of training, and that training will put them to the test.
It's equivalent to a pilot trying to practice landing a plane with multiple independent failures going on at the same time. So it can get quite intense.
Bruce, we've lost the startup and backup transformers. DG 1, 2, and 3 are powering their buses.
We have lost the startup and backup transformers. DG 1, 2, and 3 are powering their buses.
That is correct.
Dave, verified +1
tension in the plant, and tension in the plant.
1.68-pound actuator.
Reactor scram due to a leak in the dry well.
So it started with a leak from the reactor coolant system into our containment structure. That's what caused the initial scram. Although it would be extremely unlikely to happen at the same time that the leak started, the two independent off-site power supplies, which were referred to as the startup and the backup transformers, those were both lost. There would be no reason for those to be lost at the same time as a leak in the dry well, but it does take away much of the equipment that could have been used to help mitigate that leak. So with the systems that were left, which are just the bare minimum emergency systems, the crew was able to recover RPV level, keep the core from suffering any damage.
The control room simulator at Columbia Generating Station is the largest in the United States. That's because Columbia's control room is the largest in the U.S. The simulator is an exact replica of the control room, allowing operators to experience training and drills just as they would in the real world, right down to the position of the waste baskets.
The NRC required that each site had a plant-specific simulator built to train their operators on. Every switch, every knob, every controller, every meter must mimic exactly the way it is in the control room, from color to the way it feels when you operate it, to the response of the meters when you operate a system. We use a simulator for very basic type scenarios, especially when we're starting folks through their training program, or just simple system operation, and we slowly bring them into integrated plant operation where they are able to see how operation of one particular system may have an effect on another system or another part of the plant. And then we bring them into what we call the emergency operating procedure portion of their training, where we can run, we sometimes affectionately called crash and burn scenarios, where we take them with all different types of situations, all different types of equipment failures to ensure that they're still able to mitigate the accident and bring the plant into a safe condition.
The simulator's computers and Columbia's training team have an almost limitless number of scenarios they can put the operators through. But the most valuable training stems from real-world experiences.
We rely heavily on what we call operating experience, and just so happen to belong to an organization that provides us with a national database, actually an international database of operating experience for all nuclear power plants. And so with that, we're able to go in and look at recent situations that have occurred at other plants and take and make those into learning situations for our crews via the simulator in most cases.
The intense and continuous training is a big reason nuclear energy is one of the safest industries in the country.
Certainly, I think in my professional career, clearly the most interesting and rewarding experience I've had.
It starts with a fuel pellet. Gather enough of them together, and you can power a city the size of Seattle. Columbia Generating Station produces nearly 10% of the power generated in Washington. And because nuclear fuel prices are stable, nuclear energy continues to be a cost-effective source of electricity for Northwest ratepayers. We invite you to find out more about the benefits of nuclear energy at columbiavalue.com.
Right now, Brad, we got Tim and Craig in there. They're doing the last of the 2 dowels.
What interested me was obviously the opportunity to learn how to operate a nuclear power plant. I thought that seemed extremely interesting, understanding the technical piece of that.
Brad Sawatzke is Vice President of Nuclear Generation and Chief Nuclear Officer for Energy Northwest. In that position, he is responsible for all aspects of operating Columbia Generating Station. But job number 1 never changes.
The most important piece, as I said, day in and day out, starts with ensuring that our power plant is operated with nuclear safety first and foremost.
Sawatzke is one of only 26 chief nuclear officers in the United States. For him, it's the pinnacle of a more than 30-year career in the nuclear energy industry.
I spent 4 years operating equipment out in the plant before going through a 2-year training course to get licensed by the Nuclear Regulatory Commission to operate in the control room. So very intensive, very demanding. It really taxes the people to ensure that they understand and have a solid foundation, around their ability to operate the power plant.
It was his position as Chief Nuclear Officer that took him to Japan in 2013 to visit the Fukushima Daiichi and Daini nuclear energy facilities.
It was important to me because I wanted to see firsthand, again, how significant and important safety is to us in our industry every single day, and especially when you take a look at the tremendous power that is at our fingertips as we operate a nuclear power plant. And I believe this experience will drive that home.
Along with the other U.S. chief nuclear officers, Sawatzke spent a week engaging in safety-focused dialogue and tours of the 2 plants with their Japanese colleagues. They shared lessons learned and discussed how to improve the nuclear safety culture in both countries.
Daini is frankly amazing. They basically implemented Flex from scratch in the dark in about a 30-hour period to save those plants from melting down, finding that cable and getting it dragged on site and running it in the dark and getting it hooked up to the pumps they needed to protect the reactor. So they demonstrated Flex works, and they did it from scratch. So what it told me is when you have everything staged and ready to go, how powerful that could be and what a difference it could make. We got a chance to go down on top of the Taurus to a vent valve that they were able to manually open on one of the units to help prevent overpressurization. And you just kind of envision, again, in total darkness, not knowing what the condition of your plant is, for those operators who had to go down out into that area and up on top of the Taurus to get to that valve to manually open it, and putting yourselves in their shoes and what they went through to make that happen, and how much courage that took for them to go do it. I think that stuck out. I think the other thing that stuck out too is when you go behind the turbine buildings and stuff at Daiichi and you still see trucks and that piled up against the walls from the tsunami, pushing them up. And it shows you the fact that they've been so focused on just stabilizing these reactors that some things that you would consider relatively simple cleanup, getting in there and hauling that out of there, just hasn't been a priority. Certainly, I think in my professional career, clearly the most interesting and rewarding experience I've had. Based on what happened with 9/11, we not only beefed up the security forces at all of our sites across the country, but we also put into place a number of these pieces of backup equipment that could be there in case of some event, if you would, that would take away the multiple safety systems we have on site.
While having the right backup equipment is important, Sawatzke knows having the right people operating that equipment is equally important.
There's a tremendous wealth of knowledge and talent on our site. When I first came here, John, one of the things I was most impressed with was the quality of the people here working on the site. both their technical knowledge and their work ethic and their dedication to what we're accomplishing here at Columbia Generating Station every single day.
So it's very, it's dry, it's solid, it's easy, and you set it aside, and you really, there's not much worry about that.
We're part of communities across Washington State.
We're in big cities and small towns. But wherever you find us,
You'll find us providing reliable,
affordable, and environmentally responsible electricity.
we're public power. We're public power.
Energy Northwest salutes our member utilities and the dedicated men and women who are powering Washington's clean energy future. We are your locally owned public power utilities. We are Energy Northwest.
As part of the Used Nuclear Fuel Management Program, Energy Northwest periodically removes used fuel assemblies from the steel and concrete pool in the reactor building.
In commercial nuclear energy, nuclear waste is the spent fuel or the leftover material after you have been generating electricity for about 5 years.
The assemblies are safely relocated to the secure dry cask storage area. Energy Northwest recently completed its 4th dry cask storage campaign. During the campaign, 9 casks were loaded with 68 fuel assemblies each, for a total of 612 fuel assemblies moved to dry cask storage.
All the nuclear waste in the world ever produced would fit in one good-sized soccer stadium, so it's not a lot of material. Also, it's solid material, so it's not leaky. It doesn't evaporate. I mean, it's a solid material that you can handle very easily. All other energy sources produce a lot more waste than nuclear. I mean, because nuclear is very, very dense energy. Coal produces about 11 million times more waste per kilowatt hour than nuclear does.
The process is meticulously planned and performed with safety as the #1 priority. First, an experienced technician on the refueling bridge guides each assembly to a stainless steel multi-purpose container positioned in the pool. Once the MPC is loaded, the lid, which weighs 10,000 pounds, is welded in place. Then the canister is drained of any moisture. The MPC is later married to its concrete and steel overpack for transport to the Independent Spent Fuel Storage Installation, or ISFSI. This is where things get really slow. The vehicle that carries the 185-ton fully loaded cask to the ISFSI moves at 0.3 miles per hour. That earned it the nickname Greased Lightning. About 90 minutes later, the cask is positioned on one of 2 specially built concrete pads. These temporary storage areas were put in place to house used fuel until a permanent national repository is licensed and built.
The nice thing about the dry cask storage for nuclear energy waste is that it's very massive. It's very huge, massive. It can take a tornado, it can take a hurricane, it can take being flooded. There isn't anything nature can do to these large casks to actually compromise them.
Used nuclear fuel remains safely and securely stored, allowing nuclear energy facilities such as Columbia Generating Station to continue producing reliable, cost-effective, clean energy. Thank you for watching. We hope you've gained a better understanding of nuclear energy and the vital role it plays in powering our region's clean energy future.